Yeah, welcome to my talk. My name is Sebastian Copei. I'm from the beautiful University of Kassel, and I comes up with the question how to synchronize microservices. And if we ask how to synchronize, we also have to ask how to provide consistency. But first things first, before we can speak about synchronization, I think we have to talk about communication. And in the microservice environment, there are two main types to synchronize to communicate. The first one is synchronous via REST, and we get some problems with REST because we can destroy the consistency of we can destroy the condition of independency because maybe our student office microservices need the startup of our two departments, software engineering group or theory group. So we go a step back from microservices to a SOA architecture, and this is not what we want. So in practical use, the REST communication is used between front end and back end because the front end only wants to receive some data or short snap from the database. So in the back end, the most time we use asynchronous communication with a broker, something like RabbitMQ or Kafka or something else, with a traditional public subscribe system. And that's are the two main way to do communication. So when we communicate, we have to synchronize data. An example, we have a student office and a department, our software engineering group, and they have to synchronize data like students and grades, maybe some assignments. So in the common way, or at the actual way, we do this with POJOs in the Java EE context, plain old Java objects, or in another way, the DTOs, data transfer objects. And the problem with this is, in the most cases, these are whole documents we send from A to B, or little shortcuts. And if we want to try to show consistency, we have to compare whole documents or do model checking on whole models, and that's very hard. So we come up with a other way to synchronize, and we want to use events, shared events between microservices. Here's an example of one of this event. And to do this, we use a technique from the domain-driven design called event sourcing. And first I want to show what an event source is. In very easy words, it's an event source is just a store to store all actions from a microservice. So something like create student, enroll student to a course, create lecturer, so on, so on. And in the next step, we formalize this event source to build some consistency checks on that. I want to start very easy. I don't want to deep dive in the theoretical. This is very hard. On the upper ground, all microservice has models. So at the startup of a microservice, there's an empty model we start with, and we have events and a set of events, and each microservice has its own set of events. So then we have event types, and these event types have okay, and an event is just a tuple of types and a parameter list, and a parameter can be a number or a char sequence, something like that. So, and there are some special event types we call shared events, which are just event types we share between microservices. So there could be some events we do not want to give other microservices. There could be only internal events, like the software engineering group only do not want to share their assignment with the study office because the student office only want to know the grades and not the assignment directly. So then we can put events together to a series of events, and this series of events can apply it on a microservice to generate models. And this we done with a little function called apply which nothing does more than take an event series and apply it on the model to get a new model. Here as the example, we just take the empty model, applies the event series E1, and we get the initial model of a microservice. So, further, we need to define some conditions on our event source to check consistency. The first part is we need something like idempotent. That means if we apply event multiple times, we do not want to change the model. And the other one is the order of the incoming events should be irrelevant. So there is a little clue on this because an event needs all parameters to create itself and all corresponding objects. For an example, if we want to create a course, then the event needs every information about the course and maybe about the lecturer who do the course. This is very abstract, so I bring up a cool little example. This is a little cut from our university. We have the student office, our software engineering group, a theoretical group, and a TA pool. TA means teaching assistant, so there are stored all our little slaves which works for us. And instead of a database, we use the event source as a persistent layer. So, and the communication here could be REST or could be a broker, what else, this is not important. And this get and put events comes from the bidirectional transformation context. This get and put means something like I get a model through this service and do something, or I put my model to the service. I don't want to deep dive, this is very crazy mess shit. Here's a little example. I have one event, multiple events gives us an event series, and each service has some kind of methods to create or apply these events in form of get or create pattern. And here's a good example what I mean with event needs all informations. The enroll event did not only need the student ID, we further need the course name, lecturer name, the date of the the days of the lecturer to create all elements of this object if they're not there, because we use this get or create pattern on this way. So we think this is a good and nice way to synchronize data, and we have collect some benefits of this. First, we have the lesser communication overhead in the back end. Then we have an easy way to show consistency on a model through shared events. We only need to compare shared events to say, okay, microservice A and microservice B have the same amount and the same shared events, so both models have the same information grade or the same level of information. On runtime, of course. This is very easy on runtime and hard at compile time. Then we have more control over shared events. We can just control the informations over the shared event types. If we don't want to share the information, we just give it a type. This is not a shared event type. And we can simulate something workflow orchestration like behavior with filters or queries on APIs. We can do something like, okay, my REST endpoint needs something like a caller which says, oh, only the SE group can receive all students which are enrolled to the SE courses. So I don't want to see the students of the theory group and vice versa. But this is still need to prove. This is more a proportion which comes from our theoretical science. And there's some future work we have to do. The consistency check should be done during development time, so we want to define some consistency rules and apply with model checking this to our APIs, and in best case we can say, hey, if you implement this way, the whole consistency will not work. Then we want to extends our real world, our model, our example to a real world representation. We only have 4 microservices, it's very less to show that our event sourcing is really a good day type. And we need a good way to handle conflicts. What happens if 2 microservices sends the same events on the same object? Maybe maybe the SE group changed the name of Bob to Alice, and the theory group changed the name from Bob to Carly. What have we do on this point? There, and that is from my way. Thank you. I'm open for questions.
Questions? I have one.
Oh, okay.
I'll ask mine while walking up.
Yeah, okay.
The events keep coming, right?
Yeah.
So the event stores will get larger and larger and larger. Don't you need to take snapshots at some point in time?
Yeah, of course we need to do some snapshots after a time. We don't want to store 1 million events, of course.
So, from an architectural point of view, do you store all the events at a centralized point in your architecture, or does every microservice implement all event types on themselves, and the event types can differ from service to service?
As you like to. Of course, the event types can be changed from service to service, and of course every service can have its own database, or you can use a whole database. Up to you.
Next question. Take the opportunistic approach and go to the nearest guy.
So I was wondering if you need to keep synchronized the clocks on each microservice to this whole to synchronize. Not so easy, maybe. In general.
Yeah, of course. First, we try to handle this with our timestamps.
Yeah, the timestamps.
Yeah,
so
but in some cases, this do not does it.
Okay.
Because we have this. Where is it? We want that condition that the ordering of the events which comes in is irrelevant. That is a big point with the conflicts. We don't want to force an ordering. Yeah. No, the bad word. Yeah, everything gets better with the blockchain, of course.
How about backup? Consistency of backups.
Consistency of backups, a good point. Yeah, future work.
I have a paper on that.
Yeah.
Any
or
other
versioning. Yep.
We're ahead of time, which is kind of rare. If I had known. Questions for our speaker? Yes, that's one. No. This gentleman was first. And how do I get there? You go first.
Mountain doesn't go.
Then you hand it over to who?
So, just a bit concerned. So I like event sourcing very much. My experience with it is that it's pretty heavyweight on the development team.
Yeah.
Because they need to think about the design of how we can make this thing in terms of events.
Of course, it's easier if you start from an empty field.
Yeah. So this idea doesn't it spread the necessity to use event sourcing on a lot of microservices, namely all those that you need to synchronize. And if you start aggressively doing a bounded context, for example, and then suddenly, I mean, yeah, they are bounded, but synchronization happens quite often anyway, right? You want to keep the independence of their data. When would you start advocating for using something like this? When is it worth it? When is the complexity of doing event sourcing so aggressively is worth it?
Rather good question. Yeah, if you have an answer, good time. I think the best part is if you start on a green field. I think it's very, very hard to implement this in a big company like, I don't know, something like SAP will never use this form of synchronization. Yeah.
So my question on the side of the benefits, you said that you can simulate some kind of workflow, but this still need to approve in the same time? You said that, for example, in your assumptions that the order of the events should not be important. So can you maybe share with us some of the problems or the troubles that is facing you to prove this concept, simulating a workflow?
Yeah, this is a bigger question, and I think we should talk about that later. Yeah, that there is then I can take my laptop and show you the example directly, and then I can show it better and easier.
Okay.
Yeah, thank you.